This video will show how to run R Studio once you have installed and downloaded, of course, R and R Studio as recommended in the first lab. And once you have it installed, I will show you how to run it very easily. Okay, so you start with the mouse here, and then you say you want to launch R Studio. Yeah, it is installed, so let's open it. And once you open it, you will see that you have 4 screens. You can actually move them up and down or just right to left, etc. This one is called the R script. This is what you can actually show whatever you do. If it's closed and you only see this, you can go to View, move focus to Source, and then it will open. You can actually view that you can open the source, the console, which is that one below. The help, which is here, and the terminal is like here. Okay, so let's start with that one, and I will show you how to start with the first code. So let's say you go for a very easy computation. You say 1 plus 3, then you select the line either with the mouse like that, or just selecting here, just a full line. You run it, and the outcome is here. 1 plus 3 is equal to 4. That's great. So this is the first script you have done ever in script if this is the first time you open it. And I will show you now how to store it. Okay, you can actually store it with this save document or file save as. If you save as, let's do everything here in this folder called, let's call example R Studio, in which there are some files here, and it's starting example. Right. If you go to this window, you will see that it's starting example.r. Okay, so the .r is the let's say the extension for R Studio comments. Good. Now, as we are going to develop more things, and we can complete that with hashtag and say we computed 1 plus 3, which equals 4, right? As you can see, this is in a different color, and it's telling you that you can write any message. This message, by the way, can also be following a command. Actually, if you select that and you run it, you will see again that 1 plus 3, this is giving you our output. So we can, okay, update that file, so it's just saved again. But let's open one file I created already for you, which file, save as, and then you have this introduction R, and then we save file. No, sorry, file open file. I will go for this intro R. This is the one we are going to work with. You can see we have 2 windows here. Okay, we can skip that or leave it. It doesn't matter. And then we have this one in which there is a wide list of scripts which we will follow. So we have this one, we run it, and again we see that 1 plus 3 is equal to 4. Good. What about here? 4 minus 1 plus 3. How much is it? Equal to, this is equal to 6. Okay? Or we can go to 2 over 3, and you have that, 0.67. Or more complex operations, such as this one. It's important just to be careful with the parentheses as usual. We have this 4. We can actually do a little bit more complex operations, 10 to the power of 2, which equals 100, or the square root of 4. Okay, so these are simple operations that we can do in R and R Studio, and that are not very complicated. All we have to do is write out the script, run it, and then we have the output. Good. What about objects? What is an object? If you would say 1 plus 3, we know it's equal to 4. But then we store the result in an object that we can label Pepe, or we can label simply 4. If you select that, and you run it, you will see that we don't have the output. All we have done is just compute the 1 plus 3 returning 4. And then if we simply say 4 here, run 4, just the object 4 equals 1 plus 3, which is equal to 4. You see that? We can create other type of objects such as textual ones. Hello. We store in hello a text which is between quotes. You run it and it's stored. But now when you say hello, the computer returns hi. We can actually substitute that. Hello. Hi, nice to meet you. We store it. And now when we say hello, run, the computer answers, hi, nice to meet you. Look at the right top window now. This right top window, we have here a for, which is an object with a label, sorry, with the value equals to 4. And we have a second object called hello with whatever is inside. These are the objects we have stored. In this case, they are very simple. We can actually use the objects within a function. You can say, please compute the square root of 4 for us. The square root of 4 is 2. Or we can say square root of whatever is in the object 4. Which, of course, remember, we said that this object is equal to the sum of 1 plus 3. And then we do the square root of 1 plus 3. If you say 1 plus 19, let's say, I don't know, you run it, look at 4. This is 20. And then when you go for square root of 4, and you do the square root, oh, this is 4.57. You see? Good. What other things can we do? Well, if we have several values, 1 to 4, we can compute the mean. So this is super easy. You see, the mean of all these two values, 1, 2, 3, 4, it's 2.5. Or we can also do the sum. These are very easy operations. We can also actually go for more complex arguments such as this one. You compute the mean of a continuous variable starting with 1, ending in 3, and in the middle we have a non-available result. And you say, well, yeah, but do it anyway, because, I mean, for whatever reason, we have this value, but I want the mean. Well, it does it, and it returns a 4. So we can complicate things a little bit. Let's go now to work rather than with this type of expressions, such as we include here the values. Let's go for the data. Well, what we have to say first is where is the data? So the working directory, we set the working directory and we go to a folder. What is our folder? Example RStudio. So if we store everything into Example RStudio, I just come here, copy, come here and I say, okay. But look at what happens. Look at the bars here. They are looking at the right. When I copy, oh, they are the other way around. When I select and run, this is not working. Error. Why? Well, because RStudio is understanding the bars in a different way. If you do it now it's done. We don't have error. So the bars, sorry, we have to do it like that. It's important to store the information in a proper way. Here we have that, but let's create a new folder, which will be called data sets. We will store here any data set. Here we have one file which is called star.csv, and I copy and I move it here. So this file is here. Good. It's much better just to have this way. And now we go back here and say, please store in this object called data there directory, it's DSS. So we run it, you will have here new data there. What is it? Just a text, DSS. And now let's open a file. When opening a file, we will call whatever is included in this file, we will see in a second, we will store it in the object star. We will read a CSV file, which is in which path, in which directory. Of course, this is our directory because we set it, but there is a subfolder. Which one is it? What is the path? Data there, which is DSS. And the file is called star.csv. Now, I go back here. Okay, so we have, if you double click, you will see, okay, this is the example RStudio DSS, right? So this is a file. If you right click and open with a notepad, look at how it looks like. We have 1, 2, 3, 4 values in the first line, separated by a comma. And then class type can be small, regular, small, small, regular, regular, etc. Reading, these are the scores of the reading exam, the scores of the math exam, and then if the student was graduated or not. These are values of many observations, very long list of observations for 4 variables. If you double click or if you say, I want to open with Excel, you see this is the shape. The shape is just, again, it's in a text format, so it's not separated in different columns. Remember how to do this. We can select a column and say that our data is in text, but we want to move the text to columns. You have 2 options. Fixed width, not preferred here, just delimited. Delimited by what? By a comma. You look at how it looks like now. If you say finish, you will see that every variable is now within a, let's say, within a column. We can actually save as, come here, and I save it as star CSV, but not as CSV, please, just as an Excel star. And close it now. And then I say you have 2 files. Well, which is CSV, which is a text file, basically, and this one is an Excel. Good. This is just to know, for you to know. Now, let's go back again to our RStudio window. Here we go. And then we have that. I select and I say, listen, I want you to read this CSV file, which is in this folder, and the file is called like that. And please store everything into an object. The object is called star. We run it. No error. So it's made. So what do we see? This thing is new. You can see that this is an object, and then it's full of what? 1,274 observations of 4 variables. And there is a point here. I click, and then I say, oh, so it understands automatically that we have 4 different variables. It's said here. The first type is class type, a character variable, small, regular, regular, small, small, etc. Reading and math scores, and if you graduated. This one, as you can see, there are no decimal units, so they are understood as integer points. Nice. So we have that. But how are we sure that we have this data with us? Sorry, we follow here. You can view. If you click and run, you will see that we can view in a new window here, okay? And we can scroll down and we see every variable. So this is a way of just browsing the data. Another thing we can do, and then I closed it, as you can see, but we can leave it there if you want. Let me show it to you. We can run it. We can keep it here and then move to the next window and leaving that there or closing, up to you. You can also have a look at the head. So the first 6 rows, you run it and you see here the first 6 rows. What about the head? But I don't want 6, just 3. Well, you say head star n equal to 3. Remember, star is the object, including 4 variables. You run it and you see just 3 lines. You can also go for this dim star, which shows us the dimension of the data set, which is 1,274 observations for variables, or simply say, please tell me about the variable names, which are these ones: class types, reading, math, and graduating. Finally, we can ask for a structure. Yes, please report me the structure. The structure is basically like that. It's the same observation we have here, the left bottom corner, and here are the top right corner. Good. So this is a way of just importing data and browsing data. Let's try to describe it now. First thing we can do is just show in this window, yes, all the variables, all the observations. But look at how we refer it. Star, dollar, and then reading. So if I want to look at reading, the reading variable, it's reading within the star, which is an object. If I want to call reading, it have to be like Reading, which is within the object called star. I select that, I run it. Oh, I have all the observations for reading. What about math? I do it. Again, I have all the values for math, all the values for graduated, all the values for class type. I mean, we don't need to do that clearly, but it's a way because, but what if I want to have a look at this variable in particular? Well, you can do this without need, you don't need to show every value, but just the first 10. You run it. Oh yeah, here we go. You can see this. Good. What about frequency tables? First thing we can do, table. Please do a table of star class type. I run it. Regular, 689 people, 89 people. Small, 585 people. You see? What about graduated? 0 and 1, remember. Here we go, 0 and 1, and this is the amount of people. And then finally, what about reading? Reading is full of remember, these values are, each value is basically different from another. If we go for a table, it says, yeah, this table is too long. So I have one value with 500, the score of reading 527, etc., etc. There are some values, 644, which are observed 29 times. But this table is really, really awful, I would say. It's very difficult just to present this in anything. So let's try to build in a better way just a table other than this or other than that. Okay, and of course much better than this. So what do I do? I say, listen, I want you to build a table such as here, tables between parentheses, star, dollar, class type, exactly the same, but please store it within an object, which we will call absolute frequency. If I run it, and I say again, now, let's say here, please show it to me, you will see, okay, yeah, this is what we do. I remember it. Now, do the same, but rather than a table, please, the proportion of this table, absolute frequency, and called it relative frequencies. If you run it and you call for this, you will see, oh, nice, I have the proportions. You can also compute the cumulated sum of this table of absolute frequency, and you can call it like that, cumulate absolute values and cumulative relative values. And then finally, we say, listen, I want to build a frequency table with altogether data frames. So we call for different frames for different objects, okay? First, we start with the names. The names of absolute frequency are regular and small. Then include the absolute values, the relative values, cumulative absolute values, cumulative relative values. I select everything and I run it. And then finally, I say, display the table. And here we go. We have class type, regular and small, absolute figures, relative figures, cumulative, absolute, cumulative, relative. But you will say, come on, this is really boring. It's too long. What about, is there any other way just to do it? Yes, there are what we call libraries. A library is just something which is not just, I mean, you don't need to install everything from R. What we do is just, we call for a library. It's very likely that we do something we want for us and someone wrote that. Remember that R, it's an open source program. First we have to do is install, well, you can Google that. But if you Google that, you will find this question R library. First and only once in your computer, you have to install it. Run. You will see that they are being installed. It can be longer. It can be, I mean, it was installed in my computer. That's why it didn't take that long. And you only have to do it once. Once done, I would say include a hashtag. You don't have to do it again. Now, once installed, and now we upload it. Okay, we call for it. Every time we open R, we don't need to install, but yes, we need to call for the library. Let's call for the library. It's in the memory. And now what is it doing for us? Frequency. Oh, so this library, question R, has some commands such as frequency, which is doing for the variable class type, which is within the frame, star, within the object star, we want the cumulative values, the total values, and all the valid values. Run. Here we go. This is very close to what we were doing before one by one. Other alternatives are open. Okay, it's up to you. You're going to go for this. Let's go now for graph. So we have to learn how to present. By the way, if you want to do this, you can practice rather than the variable class type. You can try with the scores for reading. This is something you can try to do. Just try to provide everything, okay, with the variable this I mentioned. Okay, let's go for graphs. Let's start with a pie chart. The class type is regulars and small, as we have seen here. And then how do we build a pie chart? All we have to say is pi. But what is pi coming from? Pi is coming from this variable. But if we say only the variable, it will plot every value from the variable. And we don't want that. Only we want is the table, the outcomes. How many people? 689 in regular, 585 in small. This is what we say. Let's build a pie, but I want the table outcomes of the variable. And then in main, this is the main title, the column, this is the colors. We say what type of colors we want. We select it, we run it. Okay, this is great. We have it here. Pie chart of class type. This is exactly what we said here. The colors, rainbow. We can change the colors. It's fine. Okay. What if we want to save it? It's a little bit boring maybe, but you have to say copy, develop a copy in PNG format. This is the name of we want to go for, and this is the size, the width, and the height. Once you have defined everything, you just have to say def off within parentheses. So we select, we run, apparently nothing happened, but now we go for here, and we say that, yeah, we have a new file, which is this, pi class type. You double click, you have it here, PNG file. You can actually include that in your Word if you want. Let's continue. What about the bar chart? Bar plot, rather than pi, bar plot. It's exactly the same. All I do here is change the main bar chart rather than a pi, saying the lab, a label for the x axis and a label for the y axis. Okay, and then if needed, just a sky blue. But look, if I want to save directly the plot, I can start with this. Rather than saying def copy blah blah blah, I say PNG. Exactly what we did here. Just I start with that, and then I finish with def off. Look, I run this all together. I run it. Apparently nothing happens. The file is not here, but if we go to here, oh, this is where the file is. I double click, and you can see this. Okay. This is the bar chart, 0 and 1. Graduation started. Graduated, not graduated. Fine. So it's up to us if we want to show or not, whatever we're doing. Let's continue. Histogram. We can also store it, as you can see. Histogram. In this occasion, we will make the histogram of a variable that it's with many potential values, such as reading, and then we say, rather than say bar plot or pi, we say histogram. Frame or just object star variable reading, and then the label and the lab for this, what type of color, what type of border, select, run. Here we have the histogram. Nice. What about box plots? Same as before. Box plot, change of the mean. Run it. A box plot. What about if I want it horizontal rather than vertical? You see here, this is the scale. Well, rather than having this way, I want it another way. Oh, it's the same graph. The only thing is that the scale is just on the horizontal axis. There are other packages, other libraries, which are useful to build graphs, such as this one. Look, this one is called ggplot, and we install this ggplot2, which is something new. We install it. We run it. It worked for a while, and then it's done. It's likely that for you it takes a little bit longer because as I told you as before, I had it already installed in my computer. And then once installed, I only need to install it once. I put just hashtag here, so now it's text. And now I upload the command library ggplot2. Okay, you can actually learn more on here. That's nice. And then look, what things you can do with that? ggplot. We don't have to say ggplot2. First thing, the data. Where is the data? The data is here in the object star. We say star. We don't say star and then dollar and then class type. Here we only say star. And then what type of, or what is the variable? The variable is class type. Fill, class type. What is the geometry? Bar. We use a clean modern theme, so just the design. You see that we here start with a parenthesis, close parenthesis, but we say plus, and then we continue. We can write the same command in different lines. So there's a geometry bar, plus theme minimal, plus, and then the labels, title, the subtitle, the label for X, the label for Y, and finally we finish with scale fill brewer palette. This is a professional color palette. Good. You select everything and run it. Here we go. And what about saving that? Well, ggsave, right? And ggplot, ggsave. We say class type bar ggplot, the width, the height, and this is what we say that's the how heavy we want it, how is the amount of pixels per centimeters or whatever. So this is just what is the level of quality. If you run it, no error here. So we have it here. This is where is it? Class type bar ggplot. This is what we get. Good. Class type regular and small. These are the labels for X and Y. These are the headings. That's exactly what we wrote a minute ago. Everywhere. Here. Now, I want something better. So I want to plot the variable reading, but I want to compare the reading and math scores. And I want to do it in a nice way. Look at what I can do. I come to here and I ask to Copilot. Hello, Copilot. I am running an R Studio script. I copy what I have so far. Then up to here, I copy everything. Why? Because I am telling Copilot, paste, what I'm doing. Now, I'll say now, I want you to help me to build a density plot, which is like a histogram with let's say the bars are very thin, combining the reading and math variables. Use ggplot2 command. I run it, and then it thinks for a while. Blah, 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 blah. And then it should be reporting just exactly what I'm asking. I want in RStudio a result for the ggplot. ggplot. Okay, I forgot the plot here, the T, but I hope you will understand. Well, it's taking too long, but I can tell you that the outcome you can get for asking this is this one. So I did that here. This is exactly what I did. This is the Word file, which you will find in the virtual campus. And then you will find here that this is exactly what I asked. I want to develop an RStudio code for building a frequency table. Well, this is not for, this is exactly what we did before. This is the ggplot, and this is where I want a density for this. I asked this to Copilot. And then as you can see, what type of graphs can you do at ggplot? You can go for a bar, pre-computed bars, numeric distribution, a histogram, a density. This is what we want now. A box plot, a violin graph, numeric relationship, a point graph, a scatter plot. We got many options. Just one example of joint densities. This is what I wanted. Let's see if it worked. Well, it's not working. I don't know why. But anyway, this is what I got from asking Copilot before. And then I copied this as a ggplot. I want a density, geometric density for reading, geometric density for maths. The first one will be in red, the second one will be in blue. We can fill or we cannot fill that, doesn't matter. And then the labels. And the theme, I want this type of design. I copy everything and I run it. Look at that. This is very nice. So the blue is just like a histogram, but with very thin. So every dot is basically just a very, very thin column. Is that thing that we don't put every column. So we only show just the distribution, the line. And then the red one is for maths. The blue is for reading. Sorry, no, the other way around. The red is for reading and the blue is for maths. We have that. That's nice. Okay. So we can actually plot not only one variable, but two variables together. Let's continue our exercise with the descriptive statistics. And this is, we say, okay, how can we compute the mean, the median, the mode? All you have to say is summary star, and it will report you every single basic statistics for reading, math, and graduated. Of course, for this, well, this is not numeric, this is qualitative. So we have the scores of minimum, maximum, first quartile, median, mean, and third quartile. You see? For reading, math, and graduated. We can actually go for more complex statistics. We install a new library called Psych. We install it, we upload it, and then we say describe, this is what this library is doing, describe star. Look. I select, I run, it installs if needed, opens the library, and runs this. For every variable, I have variable 1, 2, 3, and 4. We have 4 variables. We have number of observations. What does it mean? It's understanding, as you can see here, that this is minimum 1, maximum 2. What does it mean? 1, 4, and 6, etc., etc. What do we have? The mean, standard deviation, the mean, trim media. I don't know what's that. Mean, max, range, skewness, kurtosis, standard error of the mean. We will see many of these things in new lectures, but as you can see, it's very easy just to collect basic statistics. Another one, packages. The new package is called SchemR. You're running. We install it, we open the library, and then we run it for this star. If you run it, what is the outcome? Oh, this is more complex. As you can see, we have here number of rows, number of calls for the variable character We just qualitative variable, we have just one. Quantitative variable, we have 3. As for this class type, we have, well, this is a type of some statistics. And here you can see we have the reading and the math scores. We have some additional information, which is similar to the one we had before. But in the end, we have a small histogram for this, which is okay. What else we have? What about the quantiles? I just not only want the first quartile, the median, and the third quartile. So I want more. You want to compute the quartiles? Look, quantile of variable reading. And please, the probabilities are 5%, 10%, 25, 50, 75, 90, 95. You select it, you run it. So for variable reading, the minimum is 527. The maximum, 753. And what about the quantiles? These are. So with this simple command, you can run this. So we can actually show the histogram. Here is the histogram for reading. What do we got? So 10% of the people, this is what we say here, the quantile 10%, it says that this is 583. So 583 might be something like that, around here. So around here, below, we have 10% of people. Oh, good. What about 90%, 675? When I come here, 675 needs to be around here. So above this number, I have how many people? This is the 90th percentile. So above this value, which is 675, here I have 10% of people. And below that, I have 90%. Look at what I'm doing. If I want to plot easily just all of this, first I do exactly the same quantile, but I only compute the one of 25%. And then I store in an object called P25. I select that, run, and now look, I say P25, run. What is the outcome? P25, the outcome is 602. Oh, okay, yeah, so this is a P25, so this is a first quartile, the value is 602. Okay, so I stored it in a call in an object called P25. And now I say, now I want you to build a density plot with vertical line at the 25%. So I will do the ggplot with the density, which will be in light blue. The color is blue. This is the line width, etc. And in addition, we add a vertical line. The vertical line is just a value, sorry, a line at the value P20. What is the value of P25? 602. Okay, with the color, the same color, etc. And then the labs, and then some stuff, etc. You select that, you run it. Look at what nice. Oh, so this is the distribution. This is the density for the reading score. And below that value, we have 25% of the observations. Of course, above that value, we have 75. Remember about interpreting this value. This is the 25th percentile. This will be, this is 600, we said 602. 602 is the maximum value of the 25% of people with the lowest scores. Or it is the minimum value of the 75% of people with the maximum scores. We can do the interpretation from this side or from this other side, okay? And of course, we can score the graph. So we can save the graph and everything will be here. This is what we have created, you see? All these graphs. And the nice thing is that no matter what is your data set, you can always run this. And if this is a new year, a new course, a new report of data coming from a new client, you can run it and you will have different graphs for every client because the script is the same, assuming that the data, of course, is the same for everyone, okay? So this up to here is just the lab. You have all the descriptives of what we have here. And please remember, if you don't know how to do something, You can go to the AI. I want a plot of density of reading, plotting a vertical bar the 25% of percentile. And I want to use ggplot. It will turn out this. You copy paste, and this is the outcome. So the nice thing of RStudio is that this is super powerful. All you have to do is just understanding what are we working on. What is an object? What is a script? What is a library? If you have to install, open it, and then the outputs, where to store them, etc., etc. Hope you use it.